Hi everybody, I'm excited that you all have joined in today. I'm Professor Betsy Albright of the Nicholas School of the Environment. This video covers a brief discussion about research design. I will review many concepts and ideas that you likely covered in an introductory statistics course. We will return to these concepts many times throughout the semester, so stay tuned, and here we go. I'll start off talking about the purpose of research and then jump into research questions. We will talk about measurement and issues of validity, reliability, accuracy, and precision. I'll go over various types of research designs and modes of observation and data collection. We will talk about the temporal component of data collection and the structure of data. I will illustrate some of these concepts and ideas by discussing a paper that a colleague and I wrote on climate change beliefs in the aftermath of a disaster. So, why do we do research? And I don't mean only research for an academic publication, but research broadly. I'll define that here as seeking new knowledge. We may seek to explore, investigate new fields of knowledge, or set the frame for future studies. We may want to describe or assess a situation, get a sense of a population, a census of endangered species in a region perhaps, or a census of humans and where they live. And finally, we may seek to explain, to answer why questions. In doing so, we may want to better understand relationships between or among measures or concepts. For example, what is the relationship between national level economic development and greenhouse gas emissions? Or we might want to take it a step further and try to explain causality, although much more challenging. Does increased economic development cause increased greenhouse gas emissions? And finally, we may want to make predictions. Given current trends, what is the future trajectory of global greenhouse gas emissions? When we pose research questions, they are often informed by knowledge. That can be formal, such as previous studies, or informal knowledge, observations, or past experiences. Questions may be descriptive in nature or focused on relationships, or may be causal. Most critically, concepts in the question should be clearly defined and operationalized, or made measurable. Should be able to be measured either directly or indirectly. For example, colleagues at the Marine Lab ask questions such as, what are the behavioral responses of beaked whales to the presence of sound? This question could be causal in nature. What is the effect of sound on behavior? Researchers would need to clarify what they mean by sound, such as anthropogenic sound, and what aspect of behavior they're interested in or able to measure. Research questions are often built on theories. Theories are often developed from evidence from past studies, the accumulation of knowledge, and/or theoretic modeling. They are often focused on relationships between or among concepts. Hypotheses are more specific than theories and propose relationships between concepts that often include directionality. They're based on concepts that can be operationalized, or in other words, made measurable. Hypotheses can be tested and therefore should be clear enough to be wrong. In many studies, we hope to gain insights into causality. In essence, what is the effect of X on Y? This is often harder than it seems on the face of it. To make causal claims, variables X and Y must be correlated. Secondly, the cause must occur before the effect. And finally, the relationship must be non-spurious. In other words, the effect can't be explained by another variable, sometimes termed a confounding variable or a lurking variable. Let's look at a claim that ice cream causes swimming deaths. As ice cream sales goes up, so does swimming deaths. But can we make a causal claim that ice cream leads to swimming deaths? Likely not. We have ignored or failed to control for heat or summertime. In summertime, both ice cream sales and swimming deaths rise. It is unlikely that ice cream is causing this uptick in swimming deaths. As I discussed earlier, there are several purposes of research. Similarly, there are many types of research designs. Designs may be descriptive, where we are seeking to describe a population or phenomena. Design may be correlational, in that it seeks to examine relationships among variables, but does not focus on making causal claims. Quasi-experimental designs allow for an explanatory variable or the treatment variable to vary or be manipulated across units or entities studied, such as individuals, but those individuals are not randomized into treatment and control groups. In experimental designs, randomization of units into control and treatment groups does occur. Treatments are varied across groups and possibly through time or with multiple replications. In experimental design, it is often possible to block for potential confounding factors. There are many ways to collect data. These vary from running experiments to scraping data from websites to small and interview-based in-depth case studies. There are advantages and limitations to each approach to data collection. Small N case studies may provide a richness and nuance of data that could not be ascertained from data mining publicly available data, but may limit the generalizability of findings. Experiments allow you to control for potential confounding variables, and this may be very helpful if you're interested in studying the effects of a given treatment. That said, experimental conditions may differ from the real-world context. We are seeing more frequent use of experiments in survey design, so these approaches may overlap. Many researchers are also using a mixed methods approach that may incorporate the collection and analysis of multiple types of data. One thing we need to think about when we're designing a research study is the unit of analysis. This is the entity that we will collect data on or observe or make measurements about. This could be a nation or a state or some subnational unit, a province, a city, a neighborhood. In the ecological or biological sciences, it could be a plot or a parcel. It could be an individual, that could be a human or an animal species. A few more things to think about before we jump into a study that I, along with some colleagues, conducted, and that is the structure of data. And here, let's think about the time dimension, right? So data may be collected at one point in time, and we typically call that cross-sectional data. So it's measuring multiple units at one point in time. Time series data is collected on one unit, but at multiple times. So one unit through times. And then panel, or sometimes called longitudinal studies or longitudinal data, panel data, examines the same set of units through time. For example, looking at many nations and their greenhouse gas emissions over multiple years or through multiple years. When designing a research study, we also should think about measurement. In discussions of measurement, four terms frequently arise: accuracy, precision, validity, and reliability. So accuracy focuses on how close a measurement is to its true value. Precision focuses on how close observations are to each other, and is in essence a measure of random error. So here we have measurements that are close together or precise, but not very accurate or not targeting the center of the target. Validity gets at two different concepts. First, whether your research design is sound. This is what we call internal validity. And secondly, whether results are generalizable or external validity. Construct validity gets at whether you are measuring what you aim to measure. So internal validity focuses on whether the study design was sound and there is truth in the findings that are being made. We often talk about internal validity when discussing causal effects. External validity focuses on generalizability, or what populations can the results be generalized to. Can the results of your study be applied elsewhere? And under what condition? There are several threats to both internal and external validity that we will talk about throughout this semester. And finally, let's talk about reliability. This is, are the results repeatable? This could be through time, across measures, or across researchers. Okay, that's enough terminology for now. Let's look at a study that colleagues and I conducted over the past several years and published recently. We asked the question, do people who experience a climate-driven disaster believe more strongly that climate change is occurring? What I would like you to do now is stop the video and jot down a few thoughts on steps you would need to think about in designing a study. In essence, think about what I discussed in this video and how it might apply to designing a study to answer this question. Go ahead, stop the video, but be sure to come back. Great, thank you for returning. So what did you think about? One of the first things we thought about was the unit of analysis, and we decided to focus on the individual. We could collect individual level data a number of different ways. For example, from messages people communicate through Twitter, or through surveys that we could send out. We decided on the latter. We selected cities in Colorado that experienced a climate-driven event, a devastating flood, a flood that impacted the 6 communities to varying degrees. We decided to sample within these communities based on homes that were located both within the flood area and outside of the flood area. We decided to collect the surveys in a cross-sectional manner. Ideally, we would survey folks both before a climate disaster occurred and soon after, or many time points after, making a panel data set. But that's really hard to do. We don't typically know when a flood is going to occur, and it's resource intensive. And finally, we thought long and hard about the key concepts in the survey questions we were going to pose. So here's the question again. Do people who experience a climate-driven disaster believe more strongly that climate change is occurring? So we needed to operationalize our constructs or concepts so they're measurable. In essence, specifying how we will measure our concepts, and this could be through direct or indirect measures. And we could have single or multiple indicators. Here are a subset of the questions we used in the survey to again capture beliefs about climate change and to capture people's experiences with the flood or the disaster. We asked 3 questions about climate change in a Likert scale: strongly disagree to strongly agree. Global climate change is a very serious problem. Global climate change will harm me personally at some point in my lifetime, and global climate change contributed to the 2013 flood in my community. We also asked 3 questions about individuals' experience with the flood. In essence, how much damage did they experience at different scales? So question was, how bad was the damage from the September 2013 flood to your personal property? Secondly, we asked, how bad was the damage from the September 2013 flood to your neighborhood? And third, we asked, how bad was the damage from the September 2013 flood to your community? And the respondents rated their experience from no damage, a score of 1, to total loss, a score of 7. So what did we find in our study? As you may remember, we had 3 measures in our survey about damage or flood experience. And 2 of those 3 were found to be significant. Household damage was not a significant predictor of climate change beliefs. but neighborhood and community level damage were found to be significant and positive predictors of beliefs about climate change, controlling for a large number of other factors, including demographics. We also found political affiliation, trust in government officials, and cultural worldviews, how humans relate and view humans' relationship with the earth as significant predictors. It's important to note that we cannot make causal claims about our findings. Our design was cross-sectional in nature, and cross-sectional designs are very limited in its ability to make causal claims. Thank you for listening to today's video. I want to close out with a quick review of some of the major themes we discussed. First, there are multiple purposes and designs to research. Design of a study should fit the question posed. Across all designs, concepts should be clear, and measurement of these concepts should occur with precision and accuracy. This is important to maintain an internally valid design. We need to think about data structure and the time component of data collection. Are we looking at one point in time with cross-sectional data or through time? And finally, making causal claims is often challenging. We need to think about the temporal component as well as potential confounding variables. And finally, and most importantly, I would like to thank Matthew J. Keaty for the penguin photograph and the Duke Marine Robotics and Remote Sensing Lab for the whale drone footage. Thank you very much for joining in, and have a good evening or day, whenever you're watching it. Thank you.